to our monthly Kube chat. Today is forecast versus reality, predicting and controlling Kubernetes spin. So jumping right in here, I'm going to give a quick overview of what we'll cover today. So first, we're going to start with some brief intros, and then we'll set the stage on why forecasting Kubernetes spin is so tricky. From there, we're going to look at the signals that actually matter and how you can start connecting those numbers to real activity. Next, we're going to talk about closing the gap between your forecast and actuals. And then we'll really dig into how to make this practical. So we'll be covering how to bake this into your sprints and reviews, how to assign clear owners, and then putting guardrails in place so that all of this, actually sticks. And then finally, we'll cover how to apply this with various tools like Kubecost, and we'll leave you with some best practices that you can start using right away. We'll also wrap up the session with some Q&A. So if you have any questions throughout, please feel free to add them to the Q&A feature on your console there, and we'll cover as many as we can. And we'll also be recording today's session. So if you can't stay for the whole thing, no worries. We will be sending an email out to you probably early next week. So do be expecting that. And you can also find a PDF of today's deck on your console. So feel free to download that and you can follow us along. So we'll move right into our speakers here. So first we have Joe Dahlquist. He is our Principal Product Marketing Manager here at Kubecost. Joe has led go-to-market work across cybersecurity, cloud, fintech, and edtech, and he's shipped products used by millions. Today, he's going to really walk us through the technical core of forecasting. This includes what makes it difficult and what metrics and signals really matter. Feel free to connect with Joe there on LinkedIn. I put a link to his LinkedIn as well as his email in your console. And then our next speaker is Kai Wambacher. So Kai is our product manager here at Kubecost. His background includes building tools for technical teams in Kubernetes as well as end-to-end ML models. And he's deeply experienced with Kubernetes. So today he'll kind of walk us through the back half of the session and walk through best practices for moving forecasting from theory to practice, as well as some ways that Kubecost can help. And I also put a link to his LinkedIn and email as well. So with that, I will pass it off to Joe.
Thanks, Dee. Many of you might be familiar with Kubecost. Some of you might not be. We've been around for 6 going on 7 years now, and we have a solution that provides real-time cost visibility and insights for teams that work with Kubernetes, help you continuously understand and reduce your cloud costs, specifically those Kubernetes-related ones. We run our solution on any Kubernetes environment. That could be AWS, Azure, Google Cloud, Red Hat, OpenShift, or roll your own Kubernetes that you might be running on-prem. Across our customer base, full of really great names such as Johnson & Johnson, Coinbase, EA, GitLab, and others, we're managing more than $5 billion on behalf of our clients and helping them to reduce that and become more efficient. We've got teams across the world that are ready to help you. So welcome. We're buckle up. We're going to talk about something that I think is top of mind for everybody that is running cloud, and especially Kubernetes today. The stakes have really never been higher, right? Yes, kind of Kubernetes has won the battle to become the platform orchestration or control plane of choice, but it's certainly driving costs. I think almost 100% of teams that we talk to that are using Kubernetes in a meaningful and material way say that the cost of operating Kubernetes is one of the things that they're most frequently asked about within the organization. Why is it so expensive? Why do the costs keep going up? What can we do about it? Forecasting is a huge part of this, right? It's bad enough to have your costs always going up and to the right and not to necessarily have maybe the number of customers or new logos or users that correlate with those increased costs. But forecasting, being able to accurately predict what your spend is going to be in the future is something that can really reduce the pressure and the stress of these costs related to cloud. Most teams still rely on really outdated tools, though, things like spreadsheets and done math, back of napkin billing reports, budgets that are figured out, late in the game or even last second. And it doesn't help that Kubernetes is so incredibly dynamic, right? It's very bursty. It uses things like auto scaling. 1 minute you might have X number of resources, and then you might have 3 to 10 times that a few minutes later, based on the demand of the application and the traffic. Things like shared infrastructure, ephemeral workloads. These all break these traditional models of forecasting cloud and IT spend because it's just too dynamic. You are not you're not provided with copious amounts of accurate data to explain where those costs are coming from and what you can do about it. Historically, Kubernetes has been a bit of a mystery and a black box when it comes to those kinds of utilization and cost information. And without that visibility, without the tools to be able to attribute cost and understand the things that drive them, things like budgeting become, glorified guesswork. And it's why teams so often blow up their budgets, overrun the spend that was expected of them, and find themselves having to answer questions to teams in FinOps, teams in finance, to their managers, to other stakeholders throughout the organization, why things cost as much as they do, and how we can better forecast things in the future and bring those costs down. So, we've got some stats. I think a stat that blows my mind from the CNCF and the FinOps User Insights survey that was taken in 2023 was that for many teams, forecasting Kubernetes spend is just too difficult or not even a priority for them. And so a full 20% of teams just don't forecast their Kubernetes spend at all, right? That's like planning a cross-country trip, how you're going to get there, how much gas you're going to need to budget for, but then building the car and finding out halfway there, what your miles per gallon really are. It is a massive contributor to a lack of confidence in being able to manage costs, a lack of confidence in being able to accurately forecast budgetary requirements, an inability to properly balance the pros and cons of making investments at similar or greater or decreased levels in the future. Why? Because Kubernetes inherently doesn't really offer any kind of forecasting tools or really data that you can out of the box use to forecast what your spend is going to be. That data is also fragmented. It's spread across teams, systems, tools, things that don't inherently talk to each other or natively play well together. So the choice has been historically, do I do this by hand, spending lots of cycles, lots of energy, lots of time and stress, spreadsheets, Notepad, and try and build a forecast by pulling in all of this disparate data from disparate systems, and then refine that forecast over time to try and get it to become more accurate? Or do we focus on building more apps, building more features, fixing bugs, and just kind of moving on and deal with the repercussions as they come? I'd say that was maybe the way the world worked up until a few years ago. And I think everybody feels that the belts have to be tightened. We all have to become more cost effective and more efficient. So those bad old ways have to stay in the past, and we need to be able to get better at forecasting in the future. These gaps around tools, capabilities, data, they create real risk, right? Misaligned budgets, unexpected overages, low trusted planning numbers, budgets that never are accurate and therefore stop being taken seriously. These have detrimental impacts to your business, and there's ways to fix that. So a few things about why Kubernetes really kind of breaks this model that has worked so well for cloud, that has worked so well for IT. Number one, Kubernetes is the opposite of static, right? It is very dynamic. Workloads scale up and down. This can happen in milliseconds and in very short bursty time windows. You've got things like auto scaling. This all makes traditional kind of fixed budget forecasting super unreliable. And if you try to apply those same templates, the same math, the same approaches, they're just not going to work. You will get a budget. It will never likely be accurate unless you get lucky. Secondly, a lot of workloads are ephemeral. They last only seconds or minutes if you're lucky, right? If you're not tracking cost data continuously using real-time granular data, you're going to miss those indicators of a potential budget overrun, an uptick in spending, a trend that you might not have otherwise seen if you don't have the data that you need and in a timely fashion. Another challenge is infrastructure is shared across teams and across services. But without things like consistent labeling and tagging, or creating boundaries or some form of multi-team separation between projects or products, this cost attribution can get really, really fuzzy very fast. You need specialized tools to be able to address that, ones that can get that data in real time or near real time, attribute at a very granular and accurate level where those costs are coming from, and give you the tools and the data that you need to be able to report against that and trust in that data being accurate. Last, usage patterns of Kubernetes fluctuate constantly, right? If it's not a Black Friday sale or a marketing campaign that drives a lot of traffic to your app, it's really difficult to find a steady state place for Kubernetes apps and services. These are often driven by events like deployments, upgrades, updates, patches, variability in user traffic, cron jobs that might all accidentally run at the same time. Things like this can make cost behavior really difficult to predict, very difficult to normalize challenge. And Kubecost has been working to help teams solve this for quite some time. So let's talk about the consequences of these data gaps persisting, right? I think if you talk to most teams out there, most teams will tell you, yeah, we track CPU, we track memory, we track the network cost metrics that we can get. But if I do the math and I put them all in a column and I tally them up, the sum doesn't really match, right? They don't necessarily equate to cost. An increase in one thing, a significant increase, a 10x increase in one thing might not lead to much additional cost, while a slight variance in another might have massive cost implications. These are usage metrics, right? That most teams have available today at their fingertips. They're not financial metrics, right? And being able to translate between usage and technical metrics and cost and financial metrics is a challenge that I think every team has wrestled with. And it's one that Kubecost, I think, has really pioneered in the space to figure out and help teams overcome. Second, logs and traces might tell you what happened, but they lack the pricing context, especially when that infrastructure is shared or you can't tell where it belongs because it hasn't been properly tagged or labeled. The other thing is that these logs and these traces are telling you about something that happened historically, right? So it's like reading the Farmer's Almanac to try and understand whether it's going to rain next September. There is probably some pattern in there that you can pull. There's probably, some intelligence and context that you can derive from it. But again, the past does not necessarily predict the future, and that is especially the case when it comes to something as dynamic as Kubernetes. Just a change in electricity cost for the data center where your app might be hosted in one of its regions is enough to really throw your billing out of whack and have you overrun budgets. Lastly, the tools that teams use, right? Whether there's observability and monitoring platforms or monthly billing exports coming right from those cloud providers, these aren't built for forecasting. They're not built for financial modeling. They're built to give you, I would say, some amount of helpful information about the money you've already spent and the utilization that's already occurred, right? They're not really designed to answer things like cost attribution questions, who drove these costs, or what are these costs going to be like in the future? So there's real consequences here of not dealing with it. All right, so what metrics do matter, right? Things that you can focus on to start to get a handle on this forecasting challenge. Burn rate is a real-time pulse check for you, right? It is the heartbeat of your environment, your application. It's going to tell you how fast you're spending cloud budget. It's going to tell you how to spot spend anomalies and get rid of them before they start to show up in the bill. It's going to ensure that you don't blow out your monthly targets for spend. And without tracking this burn rate, all of your forecasting will remain guesswork. So this is maybe a cornerstone that you build a lot of your forecasting around. Next, we look at cluster efficiency, right? This helps us understand waste. How much how much of my money that I'm spending is going to things that are necessary for the performance, the reliability of my application? How much of it is going to things that are just sitting there, not helping me do anything and burning money? This waste is something that your team needs to constantly manage. This waste is going to come from things like over provisioning resources, say, requesting like 4 CPUs when you only need 1. I know that that's super popular with DevOps and developers these days. But look, your forecasted cost is always going to be a little bit overinflated, and by improving your efficiency, you're going to bring that back into alignment with what you expect. You don't just save money in your budget, you save money that is not generating any ROI for the organization. And once you get rid of that waste, it's going to help you more accurately forecast your future spend. Third metric that I think is really going to matter is granular cost allocation, right? Knowing this starts you down a path to these really great things like engineering efficiency, culture of engineering efficiency, and accountability, being able to have DevOps professionals that understand what the implications are of their day-to-day decisions around building workloads, tuning those, standing up infrastructure to operate that on, coming back and looking for ways to improve that, right? That accountability is kind of the systemic benefit that you're looking for when you start down the path of cost allocation. So when you break these things down by cost, by namespace, by team, by service, you can make some pretty decentralized forecasting possible. You can do this without live interviews every week with the people who are actually creating these things that are costing money. It becomes a lot easier for teams to predict their own future spend once they are aware of what things that they do cost. And then they can take the growth trends and their other expectations and apply that to future forecasting. All right, so let's connect these costs to some context. So cost metrics without context are incomplete. I wouldn't say worthless, but they're incomplete. You need to know why spend changes to be able to accurately forecast. Deployments can introduce things like cost changes, a re-architecture of a service, a change in the infrastructure, your platform engineering team getting rid of all of the double XL resources and replacing them with something a little bit proper. Those all have an impact on your costs. Over provisioning, inefficient code, things that haven't been tuned properly. It's all going to mount up, and before you know it, you're going to have runaway costs, and it's going to become more and more difficult to suss them out and solve them. User traffic is going to really drive dynamic scaling. Dynamic scaling is really going to drive spend. So mapping cost to traffic patterns is going to reveal your scaling behavior. It's going to help you understand days, weeks, seasons of time in which you should be prepared for higher spend, and of course, forecast that accordingly. Business activity, what campaigns are you running? Product launches are you doing? These things often affect infrastructure usage, and tracking this is going to help you to understand what those cost shifts are. Without tying these costs to signals, your forecasts are always going to miss. It's going to miss the key drivers, it's going to miss the influences, it's going to miss the inflection points, and it's going to become less reliable, and people won't believe them. So pay attention to these ways of connecting cost to context to get a leg up on this. All right. Last one here for me before I hand it off to Kai. You're going to bring lots of data into your environment to look at. It's going to help you to perform more accurate forecasting, but there's going to be a lot of noise in your numbers as well, right? Not all cost spikes are going to be meaningful. They're not always going to give you some piece of evidence that helps you understand how to more accurately forecast. You might see a sudden jump in CPU. You might see a sudden jump in memory. That could be caused by something like a failed job in a dev environment. It might not be real user demand. It might not be indicative of something that is a trend. It might just be an anomaly. Transient events might throw off your forecasts. Things like load tests, pen tests, right? Temporarily scaling something up for testing, or even just misconfiguring a job can each individually and certainly together really inflate costs in ways that aren't going to reflect future trends or spend patterns, but are going to become noise in that signal that can threaten to throw you off. So without context, cost is just numbers, right? These are just dollar figures. But if you can tie a spike in demand, a spike in traffic, a spike in team activity, a deployment, if you can get the story behind why something like cost increases, then you're going to be able to influence your forecasting model in ways that make it more accurate. Start with things like correlation, right? Tie these cost signals to operational data, to usage, to events and milestones. And then get teams to own that, right? This is going to help you filter out the noise. It's going to help you focus on the things that really matter and that help your forecasts become more accurate.
Awesome. Well, thanks, Joe. I think that was great. I think I'm going to talk a little bit more about some best practices for putting forecasting and predicting costs into practice in your organization. So, I'll start here with it's not enough to just kind of put in place a forecasting model, right? You've got to constantly update this, adjust it. Like Joe said, remove outliers, detect any variance, and really embed this into a kind of broader process in your organization. So you can kind of see here, when you put in place some forecasting, you kind of project out. And I think you kind of do this really inside Kubernetes or kind of in forecasting in general, right? If you're just trying to project, next quarter's revenue, right? You don't just say, okay, we expect to, generate $3.7 million in revenue, right? You maybe have that goal or projection, you come back, you then monitor how you did against that forecast. You try and dig into those variances that you might see, understand what might have caused it. Like Joe gave some great examples. Maybe it was like in a specific one-time testing that we had to run for some new feature. Right? Maybe that is just a one-time thing and our forecast stands for next quarter, or our forecasting model should stand for next quarter. Maybe it's a thing we missed. Maybe there's some kind of cluster or workloads or dependencies that we missed in the initial forecasting model that we can make the adjustment for the model in the future. So it's really important that you have the kind of broader process in place to do effective forecasting. It's not just about getting a model in place. Let's go to the next slide. And in terms of what a good forecasting model or process looks like, I think it's, in general, you want to go beyond just having like here's our total organization's forecast, right? Where we see teams really being effective with their forecasts is they're able to get it very granular and able to do forecasts down to individual business units, right? So maybe it's teams, maybe it's departments, maybe it's applications, right? I want to be able to understand what my various business units are projected to spend, and then how that rolls up to the overall kind of forecast for the organization. And again, once you get beyond the forecast, you need to come back and monitor it. So having the ability to do the show back reports and understand how we tracked against that forecast is kind of the key next phase, or you're kind of just not going to be able to accurately project into the future. And once you get beyond show back in general, you want to move to charge back and really ensure that your teams are held accountable for their spend, right? Like we see in general teams starting with the show back, but as they get more mature, they want to get up to a more chargeback model so they can hold their teams accountable. And you want to also have consistent thresholds, right? So oftentimes there's got to be an acceptable kind of variance from the forecast is generally what we see. You don't want your developer teams to feel constrained by the budget. You still want them to have the feel empowered to innovate and make sure they're operating to drive innovation, but you also need to make sure they're doing that efficiently, right? So it's typically what we see is teams setting up the forecast, but also trying to set up the confidence interval associated with that forecast as well. And again, I think this is true of FinOps in general, but especially true, for forecasting. Is it's got to be a shared discipline. It's got to be cross-team and cross-functional, right? So, oftentimes engineering is kind of the first line of defense, if you will, where they are the teams that you're ultimately trying to hold accountable for their spend, right? You're trying to make sure you have a good handle on what each of your applications or business units are costing you. And then you need product to be aware of that, right? You need product to start to get that kind of cost visibility or cost understanding so that when they're proposing new features in the PRD, if they are, making changes to the product, they need to have that visibility or understanding of how the cost is going to impact them, so they can make informed decisions and appropriately weigh risk and reward. Because ultimately, that's what this comes down to, cost and performance, cost and reward, right? And then, of course, this runs all the way up to finance. As a member of the product team at Kubecost, we get questions from the finance team all the time, right? We have a monthly sync with our finance team where we actually use the Kubecost product to show the finance team a forecasting report to help them understand, okay, here's how much each of our applications or customers are costing us. Here's what we're projecting to spend. Here's some of the new features and how we expect those to impact our projected spend. So we really do kind of spend about an hour every month with our finance teams, and we get into the weeds with them, right? We're not just saying, hey, here's our total expected spend for the next month. We're getting into the weeds. We're trying to show how each of the applications are impacting the spend. We're trying to show how each of the teams are impacting the spend, and how each of some of the new features and new testing that we're putting in place will impact our spend as well. So it's really cross-functional, and again, I think this speaks to forecasting, but FinOps more broadly. I touched on a little bit of this, but weekly cost stand-ups can be really effective as you're starting out. I think as you evolve and mature, you can maybe move this to monthly. And you can actually, hook this into some of your sprints, right? You can start to, see cost impact in your PRDs, in your JIRA tickets and things like that. And you want to make sure you have good, effective dashboard hygiene, right? This is key, especially when you're trying to, take the forecasting from the product or engineering level up to the finance or executive level, right? So Kubecost has some of these great dashboards to help, but we see tons of teams taking our kind of forecasting APIs and piping that into Power BI or their dashboard of choice, or maybe just their other processes. And you also want to make sure you have guardrails in place, right? I think once you start to gain confidence in your budgets, right, you want to ensure once you have confidence in your forecast, you want to make sure you have budgets or guardrails in place to actually start to enforce or alert on those thresholds or forecasts. So, it's not enough just to say, here's what we're projected to spend. You need to be actively have guardrails in place that are actively monitoring how you're tracking against that forecast. Or, like Joe said, otherwise a forecast is just kind of a number and not like a thing to drive efficiency. So how does this look in Kubecost? Let me dig into this a little bit, and how can Kubecost help with your forecasting a little bit? So Kubecost does have a machine learning model built into the product, which can give you forecast estimates really at any granularity. And this works for all of your Kubernetes spend, so cluster, namespace, workload, all the way down to the container level. You could do custom label here as well. But this is also going to work on your cloud cost dashboard as well. So if you want to understand the forecasted cost for a given tag in your cloud costs, or a given service, we can do that as well. We are using a ARIMA-based model I'm happy to provide some resources on what ARIMA models are. But essentially, for those of you who aren't experts in machine learning or data science, ARIMA models, what they're really good at is detecting like seasonality or time series based patterns. So for instance, if let's say you're trying to do a forecast on a namespace, right? And maybe that namespace spikes every Monday as users log into the system. Or maybe it spikes once a month or on the first of the month for some reason, right? It will be able to kind of learn those patterns really well and incorporate those kind of patterns it sees into your forecasts. So that's why we've picked it as the model of choice, is because, again, it's going to do a really good job at detecting patterns in your time series data. And this model is going to kind of continuously refresh every day as new cost and usage data arrives, right? So we deploy the model and it's going to be trained on your data. It does take about a week for it to have, maybe even 30 days we see sometimes, for it to have enough data to really give you effective results. But it is totally trained on your data. So you don't have to worry about some of the like security or compliance concerns that would come with having this model be trained or kind of trained across multiple customer data sets. That kind of cross-pollination does not happen. It is trained on your data and your data alone, which is good and bad. Again, like it's dedicated to your data. It's going to be better at detecting any patterns in your data. The downside is it's just going to take a little bit more time for the model to really start to be effective. And the other thing you'll notice here is we do show the confidence intervals, right? So in this screenshot I've placed here, in the model feels pretty confident, right? In general, it will typically feel pretty confident in this spend for the next, kind of 3-5 days. But as it starts to project further and further out, of course, it's less confident, right? So what we're showing here is the P95 confidence interval. And you can see it's going to grow as the model is trying to project out. This is obviously a forecast from our demo environment. So it's going to be pretty flat and stable. So it's maybe not the most interesting representation here, but in general, you can kind of see that the model will take the confidence intervals into account and try and represent that to your users or your executives as you report up. And you can kind of see in the total row as well. The projected number is like 7,700, but we're 95% confident, or the model is, that it will fall somewhere in between 5,300 and 10,000. So what we see a lot of teams do then is kind of take this budget, or take this forecast and then wire it up to the Kubecost budget, right? So you can kind of say, okay, we've got this namespace, let's say, for this team. This is the projected amount. Maybe we'll go at the high end and say, P95 confidence of 10,000. We'll put in 10,000 just to give some cushion to the team. And we're going to set a budget of $10,000 for this namespace in the Kubecost product. And you're going to be then alerted to any potential overruns, or as you start to approach that forecasted value, now you can have alerting configured such that you're aware of when you're approaching your forecast through the budget's capability. So as you kind of mature, you start to go from like, okay, this is a great forecast, it helps me get this number, to okay, I am actually going to set a budget based on this forecast and enforce either soft through alerts or hard through a mission controller. I'm going to start to enforce these forecasts as budgets. Another really cool kind of forecasting capability that Kubecost has is our Predict API. So you are able to actually forecast or predict, I guess those words are kind of synonymous, the cost of a workload or a change in a workload before you even deploy it. So the way this works is the Kubecost Predict API, you can point it at essentially the YAML manifest that requests the resources in a given PR. And it can say, okay, it's going to increase it from, 15 CPU millicores to 30 CPU millicores. Here's an estimated cost associated with that change. Or maybe it's a new workload, right? And the new workload is requesting 30 millicores of RAM and 30 millicores of CPU and a gig of RAM. Okay, well, here's the estimated cost associated with that. So you can actually start to get costs before you make a change or before you deploy a new workload. So we have an API set up for this. It's called the Kubecost Predict API. We also have a number of integrations for this API. So number one, we have a GitHub Actions integration. You can kind of actually see this in the screenshot here, where this API is integrated in Kubecost Actions, and it will automatically make a comment in your PR giving you the costs as you see here, right? So you can see each of the containers that are being that have resource requests changing in this PR, and you can see the cost per unit and the estimated monthly cost impact associated with this PR. So you hear a lot of this like shift left trend going on in FinOps, and I think this is like a key piece of this, right? How do I shift left my cost visibility? Meaning, how do I give my actual engineering or application development teams more visibility into the cost impacts they're having? This is one of the most requested features for that right now, before they even make a change. It's not reactive, it's proactive. Before they even make a change, we can understand the cost impact. So we also have integrations for this into the kubectl cost admission controller. So you can actually see this. It doesn't have to be in the GitHub, in a GitHub PR or comments in a GitHub PR. You can see it in your CLI through the kubectl cost admission controller. You can also integrate this with Kubecost budgets and Kyverno. We have a really cool blog up on this where Kyverno, for those of you who don't know, is an open source policy engine. And if you're running that, you can integrate Kubecost budgets into it and essentially say, okay, this namespace, we have a budget of $10,000, let's say. And we are about to make a change in some PR, and this PR is projected to cost $1,000. It's gonna have $1,000 cost impact. Well, that is going to, the Kyverno policy engine will hit the Kubecost budgets API. It'll see, okay, the budget is $10,000. We're maybe at 9,500 of that budget, and this change is going to cost $1,000. That's going to put us over budget, and the Kyverno policy engine will block that change from happening. So it's a really cool way that if you're running a super mature FinOps practice, you can enforce the budget by and actually prevent any overages of that budget through this functionality, because we can predict the change, the cost impact of the change. We know your budget, which in super mature organizations, that budget is dictated by the machine learning powered forecast. And you have this like really powerful way of not only setting your forecast, but enforcing it and making sure your organization can't possibly go over that forecast. So again, we typically see this at really mature FinOps organizations, but it is, I would posit that is kind of like the gold standard for running FinOps and leveraging forecasting and prediction of cost impact. So some other best practices, you want to make sure you have effective label coverage, right? Because if you're doing forecasts and you're only doing it on a subset of the workloads because not all your resources are tagged appropriately, huge blocker, right? So you need to make sure you have effective labeling, and a lot of teams will try to enforce that in their CI/CD tools. You want to make sure you have variable time length forecasts. So sometimes, you want to project 7 days, sometimes it's 30 days, sometimes it's a quarter, but it's important you have all these different time thresholds set up so that, because there's going to be different confidence intervals, right? We're going to be pretty confident about what we're going to spend in the next 7 days, a little less confident in 30 days. If you ask me to project a quarter out, it's like, okay, there's some real variables there to account for. I think we touched on this a little bit, but you want to make sure you're actively tracking any forecasting errors so you can make the appropriate, outlier removals or, adjustments in the model that might be needed. And again, I think I touched on a lot of these already, but you want to make sure you have team level granular forecasts. You want to make sure you have, efficiency gates and guardrails like budgets set up. And you also want to make sure shared costs are involved in your forecast as well. You can't underestimate the cost impact of shared resources like the Kube system namespace or something like that. You got to make sure those are appropriately shared and forecasted across your different teams. So, Joe, do you want to kind of highlight some of the key takeaways here?
Thanks, Kyle. So, a couple things to think about as we wrap this up. Number one, make cost like a first-class citizen in your work, right? It is important data. It's data that doesn't come out of the box from your cloud service providers necessarily, certainly not in the level of granularity and in the timeliness that you need it. Join your billing and your cluster telemetry data together to find that context, align your data with milestones like deployments, traffic spikes, events like massive sales or campaigns to better understand what the cost impact of those kinds of events are. Number two, forecast where the work is happening, right? Build a per team, per service model with clear assumptions, that it adheres to kind of multi-team, multi-cluster best practices, and then roll those things up later so that you can understand it at a macro and a micro level. And then close the loop weekly, right? Don't just let these things dangle out there. Compare forecasts versus actuals. Don't do this at the end of your budget cycle. Don't wait a month or 3 months to do this. Do this on a weekly basis, preferably in a room full of the people who can answer questions about why there might be some variance here, and then update your model to accommodate your latest findings, newest information, changes in trends or patterns. Kai, you want to grab the next couple?
Yeah, absolutely. So, filtering the noise before you act, like I mentioned, it is a machine learning model that is running in the background. And, like I mentioned, ARIMAs are really good at picking up seasonality. One of the downsides, again, no machine learning model is perfect, of course, but one of the downsides is it does have a tendency to really index on outliers and spikes like that. So you really want to make sure, if there are spikes in your spend, like Joe mentioned, that they're real spikes, that they're spikes you want accounted for in your forecast. We see all the time somebody made a change accidentally. I've done this as a machine learning engineer, deploy a neural network, and didn't know the cost, or it was a mistake. You don't want that factored into your forecast, simple mistakes like that. So you want to make sure you're filtering out that noise. And then, operationalize this, right? Like we've mentioned throughout, FinOps, but, in general, but especially forecasting, it's not going to be effective if you just kind of, set it and forget it. It's an active process. It takes cross-team collaboration and, active management.
Fantastic. All right, looks like we've got a few questions that have rolled in here. We could take the ones that have come in live here. We also had a couple of pre-submitted ones. All right, first,
Go ahead.
take it away, Dee.
Yeah, I think we already covered the first question here kind of in the slides about Kubecost, but I'm going to go ahead and just repeat it just in case it was missed. So the person said, sorry if this is going to be discussed later, but I'm curious, how does Kubecost make forecasts? Is it using a neural-based AI model or just some classical statistical operation? And then someone also wanted to know if when we say a quote model update, is that a manual process? So I think there's a few ways we can answer those. So I'll let Kai start.
Yeah, absolutely. So it is not a neural network per se. It is a machine learning model. ARIMA is a type of machine learning model. It's not quite a neural network. I'm happy to dig into the logic there, maybe offline. But we did a lot of research and felt that ARIMAs were well suited to the problem we were trying to solve. I think that there are a number of other use cases you can see where cost forecasting is done by an ARIMA model. And in general, one of the things we found in our research was that a neural network would have been maybe a little bit overkill here, and would be maybe better performant or more necessary for this use case if there were more data that we could factor into the model. But unfortunately, really the data we're trying to consider is just past spend to predict future spend. If there were a bunch of other signals, I think a neural network would be more appropriate. And then to speak about the model update, so there's a number of ways you could go about, can and should go about updating your model. So the actual retraining of the model is totally automated in the Kubecost product. That said, right, things like the outlier removal and some of the other pieces may be a little bit more manual. The model itself will retrain on the data it has and sees automatically, but there are some ways that you can kind of tune the hyperparameters or clean the data going in that will have a big impact on the model that are just in general a little bit more manual in the process.
Yeah, and something to keep in mind, right? There's no telepathy involved here. So no tool is going to know that you have, as a part of your roadmap, launching 2 new apps this year, or that you're going to spend X amount of engineering cycles, working to make something more efficient, but that hasn't been realized yet. There's a lot of snowflake and unique per customer, per department, per product, per team data that needs to be considered when you're updating your model. So this is a classic kind of human meets machine kind of solution where you're going to have to bring data to the table, and other stakeholders are going to have to bring data to the table that a tool could never know about, that will impact your forecasting and ultimately the accuracy of that forecasting. So that's where it has to be a cooperative work.
Awesome. Thanks both. We also had a couple pre-submitted questions, so I think we have time to do maybe 2 of these. So the first one is, someone wanted to ask about the best way to track customers' egress data charges from a Kubernetes clusters, which hosts multiple client namespaces containing various application pods. They want to ensure that the clients can be tracked and potentially cross-charged for their usage. It's kind of a loaded question, so we had to break that one up a bit.
Yeah, I would just say, I'm not sure that this ties tightly with forecasting, but in general, Kubecost does have some really powerful network cost monitoring functionality. You can install, it is optional, but you can install our network cost daemon set. That daemon set is obviously, by definition, installed on each node, and it will read the network traffic coming right off the kernel on each node. And then it's able to kind of give a cost for that network traffic, and then you as a user are able to kind of build out the reports to allocate that network cost to various teams, applications, business units, et cetera. So that is a very core use case and foundational use case to Kubecost that we offer. We have a whole page called Network Cost Monitoring that you can check out.
Great, thanks, Kai. And the last question that we'll end with today is someone said they were looking for precise real-time cost and trend estimation to connect it to monitoring tools and treat as production metrics.
Awesome. Yeah,
another great use case.
Is a great use case. Sounds like, I don't know which user submitted that, but I would love to connect with you and maybe use this use case to help power our next webinar on forecasting, because that sounds like you're doing some real mature stuff with forecasting. But in general, yes, this can be done with Kubecost. We, like I was mentioning, we do have real-time costs that come in, and we have the machine learning model in the background that's going to constantly be updating and provide you new forecasted costs at any granularity that you like. And of course, all data in Kubecost is backed by a publicly accessible API that you're able to hit to pipe that forecasting data into any kind of tooling process or dashboarding that you like.
Indeed.
Great. Thanks, Kai and Joe. So I wanted to end with some resources. If you download the PDF that's on your console, you can access these. So we included a link to our most up-to-date documentation, as well as a couple Kubernetes guides that aren't specifically about forecasting, but they do kind of dig into some of the things we discussed throughout about, just kind of initial monitoring and making sure you're setting up your labels correctly so that you can set yourself up for success to actually start forecasting. And we also just launched a new landing page for our webinar series. So I included a link to that as well. You can find every single webinar we've ever hosted there. We've been doing these since 2023, so we have a lot of them. But you can also find all of our upcoming webinars. And the next one we have is on September 18th. And we'll be talking about the hidden cost of idle Kubernetes resources and how to manage those. So I hope you'll RSVP to that one, and we will see you there to learn more. But for today, that is all. Big thanks to both Kai and Joe for walking us through all this. And I hope everyone has a good rest of your day. Thanks. Bye, everyone.
Thanks for joining.